So in this video, we're going to go over problems that are similar to what's in part 2 of your Unit 4 test. So let's look at this first question. It says the researcher finds that the temperature of the water in the ocean varies according to the depth. The following table shows the temperature of the water according to the depth of the ocean. The relationship between temperature and depth can be modeled using a linear function. So in part A, it says write a linear function that best models this data. Let's round all decimal values to the nearest tenth. So also in part B, it says determine the correlation coefficient R to the nearest 100th. So we want to make sure that that function is turned on in our calculator. So to do that, you click second and then calculate. You can arrow down. Remember, we're looking for diagnostic on. So you can also choose D, and we'll take you closer to that on the calculator. So you choose diagnostic on, hit enter, and then enter again. When it says done, that means that feature is turned on. So now we're going to go to Stat, hit Enter on Edit. We're going to clear the values that are already here. So in L1, you arrow up, click Clear, and then Enter. In L2, you arrow up until the title is highlighted, click Clear, and then Enter. So in L1, we're going to enter all of our X values. So we're going to enter 50, 75, 100, 150, and 200. In L2, we enter all of our Y values. So we enter 18, 15, 12, 7, and 1. So now we need to write the linear function. So you click Stat, arrow to calculate, and then choose option 4, which is linear regression. So you hit enter and keep hitting enter, and then you click enter on calculate. So now it tells us all the values we need. Right? So we're going to use this to write our equation. So we're going to round to the nearest tenth. So we have y equals negative 0.1x plus 23.4. So now it does tell us the correlation coefficient, which is negative 0.9994. So to round it to the nearest 100th, it's going to round to negative 1.00. So now let's use this correlation coefficient to determine the direction and strength of the association. So what I mean by direction and strength is positive or negative, and then the strength will be weak, moderate, or strong. Okay. So if we think about this, it has a correlation coefficient of negative 1.00. So this is actually a perfect negative association. Okay. If you want to do this on Desmos, I'm going to show you how to do this problem on Desmos right now. So remember, you click plus for add an item, and then you choose table. So we're going to enter all of our X values here. So we have 50, 75, 100, 150, and then 200. In Y, we enter all of our Y values. So 18, 15, 12, 7, and 1. Now we need to tell Desmos to approximate a linear function. So we're going to say y1 is approximately mx1 plus b. Okay, so now once again it tells us the same value. So m is negative 0.1 and then b is 23.4. Once again it tells us the r value is negative 0.9994, which is rounded to negative 1.00. So we have a perfect negative association. So you can see here it is perfectly negative by the line that Desmos does graph for you. So now here it says a student graphed f of x equals x and g of x equals f of x plus 2 on the same coordinate grid. Please describe how the graphs of f and g are related using vocabulary words from the word bank provided. So remember, we can go ahead and graph this in Desmos to give us a picture of what's going on. We have g of x equals f of x plus 2. So if we zoom in, we can look at the picture of these two graphs. So we know that the x plus 2 is inside the parentheses, right? The plus 2 is being added to the input. So when it's being added to the input, we know that we have a horizontal shift. Okay, this graph is going to be moving left or right. Well, because it's a plus 2, we know that it's going to move left 2 units. And you can verify this on the graph. Like if I look at the point 0, 0, notice that the transformed graph has the point negative 2, 0. So every point on this graph is going to be shifted left 2 units. If you want to, you can also write the equation. The transformed equation will be g of x equals, we're going to plug in x plus 2 into x. So we have g of x equals x plus 2. Remember, you can also use that to figure out the transformed graph. So in this problem, it says a student graphed f of x equals x and g of x equals 3 times f of x on the same coordinate grid. Please describe how the graphs of f and g are related using vocabulary words from the word bank. Well, here we have g of x equals 3 times f of x. So notice that this graph in red is steeper than the original graph, right? So we can say that it is made more steep. So what happens here is we have a 3 in front, right? A 3 is multiplying the output. So remember, when we have that, we have a vertical stretch or a compression, right? From our chart, we know that that is what's going on. So this is going to be a vertical stretch because 3 is actually bigger than 1, right? So remember, it tells us in our chart if that number in front is bigger than 1, it is going to be a vertical stretch by that factor. That is why, in fact, the graph is more steep. Remember, we can also tell that it's more steep because if we plug that into the equation, we get g of x equals 3x. So 3x will have a slope of 3, whereas the original graph only had a slope of 1. So that is why the graph is made more steep.